Alright, hello and welcome to a tutorial on smart pointers. So, we're going to go over a couple topics today, uh, ultimately leading up to smart pointers themselves, which is a very useful tool that you can use in your C++ arsenal. My name is Dallas Dominguez, and the knowledge that I obtained for this video is actually from a really good book called Starting Out with C++ 8th Edition by Tony Gaddis. And so without further ado, let's get started. So today we're going to demonstrate why smart pointers are indeed smart, but the first thing that we need to do is talk about where they originate from. And so you've probably heard the concept of dynamic memory allocation, and what that is that variables can be created and destroyed while a program is running. What that means is that to dynamically allocate memory in a program, it means that while it's running, you ask the computer to set aside a chunk of unused memory large enough to hold a variable of a specific data type. So here I have a little example that we're going to walk through just line by line, just to get a feel for dynamic memory allocation or to review for some of you. So in our main function, we create a pointer to an integer. And so here we've created a pointer and we just initialize it to null pointer. And then we're going to request from the computer to allocate enough memory for a integer variable. And so here we're using the new operator. And what this is going to do is now iPointer will contain the address of the newly allocated memory. So the new operator allocates memory for us. Next, we just do some standard stuff. So we're going to assign a value to this new integer right here. Notice that we dereference it. And then we just print it to the stream. So print to the screen. And this is a very important step right here, which is you have to delete the allocated memory so it can be used elsewhere in the future in the program. Every time you use new, you have to delete the memory that you allocated, or else you're going to get a memory leak. And this is going to cause like a lot of errors in your bigger programs that you have to write. So without further ado, let's just run this code. Notice that it just printed 25 to the screen, so that's cool. That's dynamic memory allocation. This is not really a practical example. Like, you'd never use dynamic memory allocation to just, declare an integer and then later delete that. Usually what you use, or a more practical example, is what we see here. So we'll walk through this program line by line. This time we're going to dynamically allocate an array of integers. So let's get to it. So this program totals and averages sales figures for any number of days. And the figures are stored in a dynamically allocated array, which we'll see in a second. So we clear our necessary libraries. And then I put this here. Typically we don't like to use that, but I just put this here because of some of the stuff for formatting the output later on. So we jump into our main function. We're going to define a couple things here. First, we dynamically allocate, or we don't dynamically allocate yet, we define a pointer to a sales double, and we initialize this to null pointer. You'll see why we do this later on when we dynamically allocate the array, but that's what that's for. We have an accumulator, and then we have something to hold the average sales. We also have two integers, num days and count, which are going to hold the number of days of sales. And this is going to be a counter variable that we use in our loops. So the first thing is just get the number of days of sales. So we're going to ask the user for how many sales figures do they wish to process, or how many days of sales figures. And they're going to enter a number into the command prompt. So here is where we actually do the dynamic memory allocation. So we're going to dynamically allocate an array large enough to hold that many days of sales amount. So whatever they entered here, we're going to dynamically allocate a double array of that size. Next, we just go through some standard program stuff. So like get the sales for the figures for each day. So we output to the stream, enter the sales figures below. we go into a for loop. This is going to display the day and then the sales according to the array that we dynamically allocated. Notice that we can just index it just like this, so it's nice and easy. And then you calculate the total sales just by going through the loop and then adding up the sales as you go along, or each element of this sales array. Calculate the average sales per day, typical average calculation, and then display the results. This is just formatting stuff. This is going to display something nice. The most important part here is notice that at the end we have to delete the memory we dynamically allocated. And then this is just making the pointer to sales a null pointer again. So let's run this program, see what it does. So the program down here, as you can see, it's asking me how many days of sales figures do you wish to process. I can just enter whatever, so we'll say like 5 days. Day 1, let's enter 898.63. Day 2, 652.32. 741.85. And then 852.96. And then after I enter this last one, we should see the results. So it should show total sales and average sales, which is what we see right here. So very cool. And again, it's important to delete the memory that you dynamically allocated. Now, you got to imagine that when you write bigger programs, this is going to become an issue that you have to remember to delete all of the memory that you dynamically allocated on the heap. So in C++11, they actually came up with a strategy to make it so that you don't have to remember to delete the data that you dynamically allocated. And that's where smart pointers come in. So let's talk a little about smart pointers. The purpose of them is that smart pointers are objects that will work like pointers, but they have the ability to automatically delete the dynamically allocated memory that's no longer being used. And so this helps to prevent memory leaks or patch the problems that the new and the delete operators start to spring up. So there's 3 types of smart pointers. There's a unique pointer, which is what we're going to show today. There's a shared pointer and there's a weak pointer. And when you use the smart pointer, you have to include the memory library. So that's what I did here. You'll notice I have IOStream and then memory. So let's jump into an example because that's the best way to learn. So here we're going to define a unique smart pointer named PTR or pointer that points to a dynamically allocated integer. So let's talk a little bit about the structure of how we're defining this here. So first off, the notation int. This is our unique pointer. This is how we define it, and then we're in the standard namespace. This is the type or the data type that the pointer will point to. This is the name of the pointer. And then this is the expression that dynamically allocates the memory. So it each has its separate little components. Then we just pretty much do standard stuff. So assign the value 99 to the dynamically allocated int, and then display the value of the dynamically allocated int right there. So let's run this program real quick, see what it does. Boom, it just displays 99, cool. Important to note that there is no delete statement here, right? It's not like the typical new and delete that we had before. So we don't have a delete statement to free the dynamically allocated memory because the smart pointer will auto delete it for us. So again, let's jump to a more practical example where we're working with an array. So this program demonstrates a unique pointer pointing to a dynamically allocated array of integers. This program basically it's going to ask the user how many numbers do you want to enter. They're going to enter the amount of numbers they want to. It's going to define a unique pointer smart pointer pointing to a dynamically allocated array of integers. So that's what this is. Notice inside here the type now is an integer array, and when we do our dynamic memory allocation, we dynamically allocate an array of integers according to the size that they entered. We're going to get values for the array. That's what this loop does here. Notice again, we're just array indexing here. And then we're going to display the values in the array. So finally, just display what we see or whatever they entered. So let's run this code, wrap this up. All right, how many numbers do you want to enter? I'll say 5. I enter 1, 2, 3, 4, and 5. And after I enter this, it should display. Boom. So very cool. Again, we didn't have to worry about deleting the dynamically allocated memory. And you can clearly see the advantage of smart pointers, especially in large scale programs where you have to remember to delete all of the memory on the heap that you used. So I hope this was informative. I hope the examples help to explain it. I always find that examples help me out in the best way. So thanks for watching. Until next time, have a great one. See ya.